Now, in the case of the iOS XR routers, there's a couple other minor steps beyond this. So on XR1, we're going to say globally that we're running MPLS LDP. And then under the ISIS process, we'll say MPLS under what address family IPv4, MPLS LDP autoconfig. So if we show config, fairly similar. The only difference is that globally we're enabling the LDP process first. So the same commands we're going to do on XR2 and XR3. And commit the config. Okay, once this is done, we should start to see some log messages that we're starting to establish label distribution protocol adjacencies, LDP adjacencies. We see from router 1's point of view, it says I have a peering that's up to router 2 and to XR1. XR1, 2, and 3, they have this logging disabled by default. But again, you can turn these syslogs on, and it probably is a good idea to enable this so that if you do run into a problem later and the neighbor goes down, that you get a notification for it. So specifically what this would be, like on XR1, if we look at the show log, right now, syslog logging is enabled and we're logging to the console, but the problem is that LDP logging is not on. So if we were to say show config commit changes for our last one, okay, these are the changes we just made. So let's say roll back the config, last one change. That's going to undo what we just did. Now we're going to go to global and say under MPLS LDP, we want to log the log neighbors, and we'll say log adjacencies. Okay, then we'll paste the rest of the config back in. Okay, if we show config, the same thing as we did before, just the difference is that we have logging enabled. Okay, we commit the config, we should see XR1 gets a log message saying that it's establishing LDP adjacencies with router 1 and with XR2. Okay, next let's look at this from the final traffic flow. So again, configuration-wise, the only thing that we changed is we enabled LDP on all interfaces, and we already had ISIS routing that was giving us reachability between the loopbacks of the provider edge routers. In this case, the provider edge routers specifically are XR1 and is trying to transit the traffic out to XR3. Or likewise, router 2 is trying to transit traffic that goes out to XR4. So from the eBGP device point of view, so from router 8, nothing should have changed in the control plane, nothing changes in the routing table. Okay, notice here the route says it's almost 2 hours old, so there was no route flap. But if we now do a ping, we can see now we can reach the destination. Now, if we were to do a trace route to this, what it should show us that is different is that in the core of the network, we're going over an MPLS label switch path. Now, in reality, this is only a one-hop label, only a one-hop tunnel, because XR1 is only 2 hops away from XR3. I'll talk about this in much more detail later, specifically why that is the case. But the point being is that we do have reachability without having to configure any other type of tunneling techniques. So again, is this the same type of logic as if we were to configure a GRE tunnel between router 1 and or XR1 and XR3? Or if we were to configure an IPsec tunnel, an IP and IP tunnel. If this was layer 2, it could be a Q and Q tunnel. The point is that there are devices in the middle that don't need to know about the source of the traffic or the final destination. The only thing that they care about is that traffic is coming in on a tunnel that is sourced from XR1, and it is going out to the tunnel destination that is XR3. So from XR2's point of view, when we look at the show route IPv4 unicast, since it already knows the IGP routes to 11 and 13, And since LDP is enabled on all interfaces running ISIS, it means that we're automatically going to have labels that are associated between the two of them. Now, likewise, if we were to even go one step further, and let's say XR3 is no longer going to run BGP. So we have BGP only on router 3 as it goes out towards router 7. So on XR3, let's say no router BGP 1, and then commit. From router 8's point of view, if we do our trace route again, the only thing that we should see change is that we're now going to have one additional label in the path. So the traffic should go from 11 to 12 to 13, and then down to 3 before going this way. And let's see, it may take a minute for the config to update. So let's say show route IPv4 unicast. And why did it not disable BGP? Let's say show run router BGP. Okay, for some reason, did I do that on the wrong device? I hope not. No router BGP 1 and then commit. That's kind of strange. Okay, so now it took the config now, show run router BGP. Okay, BGP process is gone. From 8's point of view, when we test connectivity, we should still be following the same path. The main difference, though, is that we now have multiple labels that are being used in order to get to the destination. So there's a couple questions here. One is, where does MPLS actually exist in terms of the encapsulation, like in the OSI model? The easiest way to look at this is to look at the actual packet capture. So let's go ahead to the machine that I have running Wireshark, and let's start a capture, and let's look at just ICMP. And we're going to do just a basic ping from router 8 to the destination. So ping 7777, source is loopback 0, and we'll say the repeat count is just 1 packet. If we look at the result of this, we can see the source of the packet was 8888, and basically what's happening is that this virtual machine is capturing on every single vSwitch segment, so it sees the packet as it's flowing through every single hop as it goes along. Where specifically it shows it 1, 2, 3, 4, 5 times. This means it sees it once here, so this is 1, 2, 3, 4, and then 5 times. Because it's capturing on basically the native segment, not the sub-interfaces, so it captures the packet multiple times. Then likewise, as the return flow comes back in, the echo response is coming in from 7 to 3, that's 1, 2, 3, 4, 5. It should see the response 5 times. So let's look at the first leg here, where the packet comes from 8 to XR1. So we'll say that this is segment 1, 2, 3, 4, and 5. And let's look at the first packet. It says this is Ethernet. Inside Ethernet, there's the IP packet. Inside IP, there's an ICMP message. So in other words, this is just native IP as the packet is being received from essentially what we would consider to be the customer edge coming into the provider edge. Okay, XR1 is going to receive the packet in. It's going to add the MPLS header, which is what we call the MPLS imposition, or the pushing of the label. So it's basically taking IP and it's adding MPLS encapsulation on top. So the second packet in the flow, we should see that this one is now MPLS encapsulated, which it is. So we see Ethernet, then MPLS, then IP, and then the payload, which is the ICMP. Now, what is specifically important about this is what is the label number. Now, the label number in this case was 16,003 that XR1 sent in this direction as it goes out to XR2. From XR2's point of view, so we go to the next, the third segment. This is encapsulated with label number 16,002. So next it goes with 16,002. On the fourth segment, it's received with no label. Okay, so this is now just an Ethernet packet with an IP packet inside of it. So now it is received in as IP this way. And then the last hop from 3 to 7 is likewise going to be a native IP packet. So Ethernet IP, then ICMP. So let's look at now from the command line point of view, what do these numbers specifically mean? What do labels 16,003 and 16,002 mean? From XR1's point of view, the way we would check this is to say, show MPLS forwarding table. Okay, the syntax here is identical between iOS and iOS XR. This is our main verification for the actual MPLS forwarding, hence the command. Now, what this is saying specifically is that if you are trying to get to the loopback of 3333, you have two possible ways that you can reach this. You can either go to 1111 or you can go to 1112. So this must mean that for some reason, router 1 must still have a route to 3. So let's go to router 1 and say, show IP route for 3333. It says that I'm reaching this via router 2. On router 2, let's show IP route 3333. And it looks like I forgot to disable one of these interfaces. So dot 23. So I want, what links do I want? I want link just 12 up. Okay, so 23 should be disabled on router 2. Okay, this means from XR1's point of view, we should now only have a single label for the destination because we only have a single IGP route. So we show MPLS forwarding table. Okay, now we have one particular label. It says the incoming label is 16,006. The outgoing label is 16,003. So what this means is that if someone else in the MPLS network sent me a packet and I receive it in, look at the header, and I say the label number is 16,006, I'm going to change the label, or what's sometimes referred to as the swap operation. So I'm going to do a swap, change it to 16,003, and I'm going to send it out interface gig 0000.1112 towards this particular next hop value. Okay, or in other words, towards this particular MAC address on the segment. So from our packet capture, that's what we saw, 16,003. Okay, next we go to XR2 and say, show MPLS forwarding table, tell me what happens when you receive 16,003 in. Well, it really means that the traffic is going to router 3. We're going to take 16,003 in, we're going to change it to 16,002, and we're going to send it out interface gig 000.1213 towards this particular next hop. So we did the swap operation. We changed 16,003 to 16,002. It goes out towards XR3. On XR3, we need to say what happens when 16,002 comes in. So we show MPLS forwarding table. 16,002 comes in. It says remove the top label of the stack. Now, if we go back to our packet capture, this is packet number 3 that came in as XR3 got it. So if we look at what happens when number 3 comes in, number 3 came in with 16,002. When it goes out on segment 4, notice what changed. There's not an MPLS header between Ethernet and IP. And the reason why is a function, we'll talk about this in more detail later, but this is called the pin ultimate hop popping, or the PHP process, which essentially means that XR3 is directly connected to router 3. So router 3 is advertising its loopback through ISIS routing, and when it advertises the label value for that particular loopback, it says that this is directly connected to me, or what we specifically call the implicit null label. So when you see this output in the MPLS forwarding table that says pop, it means that the destination is directly connected to you.